the key to simplifying radicals is to be able to find the biggest perfect square factor of this number. Now, to be able to find the biggest perfect square factor, you will probably need to find the prime factors of that number. So do you remember when you were prime factoring and you took a number and you made a little tree and you said, oh, this is 10 times 8. And then you made a tree over here and you were like, oh, this is 2 times 5. And oh, this was 2 times 4. And oh, this is 2 times 2. And you kept doing that until you couldn't make any more trees off of the numbers you got. And then these numbers down in the bottom were the prime factors. Do y'all remember that? Okay, I hate that because it takes up way too much space. So I'm going to teach you a different way of prime factoring that will allow you to organize your work a little bit more carefully, and it won't just be so scattered all over the place. So what I do is I do kind of the half box method of prime factoring, where you take your number and you write it down, and if it's not a prime number, you put it in, you kind of box it out. And you start with the smallest prime number. Does anybody know what the smallest prime number is? 1 is technically not a prime number. So you don't include 1 in prime number. Does anybody know what the definition of a prime number is?
No.
A prime number is any number which only has factors of itself in 1. So 1 doesn't work because 1 is 1. So 2 is the first prime number. And then the next prime number would be?
3.
What about 4? 4 is not a prime number because 2 times 2 is 4. That's not 1 in itself. 5 is a prime number. 7 is a prime number. What about 9?
No.
What about 11?
Yes.
Yes. What about 17?
No.
Yes. What about 19?
Yeah.
Yes. What about 21?
No.
Why not?
7 times 3.
Right. All right, so now that we've talked about prime numbers and how to identify what prime numbers are,
We have not talked about this for like 30 minutes.
let's go through and let's prime factor 80 using my special method. So what's the smallest prime number? 2. So if I have a number in the box that's not a prime number, I'm going to start with the smallest prime number. I'm going to put that number out here, and I'll divide 2 into 80, and what's that?
40.
So I'll write this number down here. If it's not prime, I'm going to box it. And I'm going to continue dividing it by the smallest prime number that I can. And then if it's not prime as the answer, I'm going to continue to box it.
Oh, I messed up.
You see where I'm going with this? Now when I get down to 5, 5 is a prime number, so I don't box it. So every number that's not in the box is the prime number. The prime factorization of 80 is 2 times 2 times 2 times 2 times 5. So what I'm saying is I could rewrite this as 2 times 2 times 2 times 2 times 5. Now, the cool thing about finding all the prime factors is for every pair of prime numbers that you have, that you multiply back together,
Go outside the box.
that will make a perfect square. So if I multiplied 2 times 2 together, that would make a perfect square. If I multiplied these two 2's together, that would make a perfect square. In fact, if I multiply all of the numbers I just highlighted together, that would make a perfect square. So that's going to change to the square root of 16 times the square root of 5. Because all the numbers that were pairs, 2 times 2 times 2 times 2, equals a perfect square. And all the numbers that were not pairs, the things that I didn't highlight, are a not perfect square. And then I can just take the square root of the perfect square, and I have simplified the radical. And I'm sure I got the biggest factor out of it. Some radicals don't contain a perfect square as a factor. That means they don't have any pairs. So if I go to a prime factor 30, I'm going to start by dividing by what? And 2 goes into 30 how many times?
15.
Is 15 prime? Nope. And now I can't divide 15 by 2, so let's go to the next prime number, 3. And 5 is a perfect square. So the prime factorization of the square root of 30 is 2 times 3 times 5. However, none of these numbers are pairs. So what that means is that square root of 30 is as simple as you can write that radical. I call that in simplest form, or ISF. So if I ask you to simplify a radical that doesn't simplify, you can just put ISF as your answer. Yes?
It only simplifies if there's pairs?
It only simplifies if there's pairs.
Okay.
Because if there's not pairs, you don't have two identical numbers to multiply together to make a perfect square. Remember, a perfect square is two numbers, its factors are the two numbers that are the same. So if you're looking at factors and you don't have two numbers that are the same, you never had a perfect square to begin with. Does that make sense?
Yeah.
Any questions? All right, so what I want you to do is real quick, I want you to practice by simplifying these three radicals. If it does not simplify, you may write ISF. All right, so when you prime factored down 20 and then multiplied the pairs back together, you should have gotten the square root of 4 times the square root of 5. I don't care if you skip directly to this step. If you look at this number and see that 4 is the biggest, then that's fine. Now, if you need to work it out, 2 goes into 20 10 times, 2 goes into 10 5 times, so that is 2 times 2 times 5, and these were the pairs. That's what becomes the 4, and this was the not pair. So what's the square root of 4? So 2 on the square root of 5 is the simplified form. What did you notice right off the bat about the middle one? It's a perfect square. If I prime factor 25, it's 5 times 5. All of the solution makes a pair. So that means it's going to be a perfect square. So simplifying it is just taking the square root of it. With the last one, when I went to prime factor it down, it didn't have a pair. So that's ISF. It's in simplest form.
So when it's asking me to prime factor...
Okay, one question at a time. Go ahead.
So when it's a perfect square, the answer is just a square root?
Yeah, if you have a perfect square, simplifying it is just taking the square root. And Stephanie, what was your question?
So when it's asking for, what is the question for this prime factor? Is that what?
The question is simplify the radical.
So the answer would be 2 times 2 times 5, not 2 square root of 5?
The final answer is what I put a box around.
Okay, that's fine.
The rest of it's just work. Yes, ma'am.
For the last one, I just circled 34 if it was in simplest form, or do I have to write IS?
So it depends on what the directions were. My verbal word directions were if you can't simplify, write ISF.
Gotcha.
Okay.
Sorry, I missed
Can I go to the bathroom?
You may. All right. So multiplication can work. You can multiply numbers together just so long as you have both of them in an identical type root. So all of the roots that we're going to be working with are square roots. So if I have two square roots multiplied by each other, what that means is that just means multiply the two numbers together and keep it under a square root sign. So what's 6 times 15? Now the question is, does the square root of 90 simplify? Well, I would prime factor 90, so that's going to be 2, 45. What's the next prime number that goes into 45? 3, 15, 3, 5. Do we have any pairs? What are the pairs? 3 times 3. What are the not pairs? 2 and 5. So that means the square root of 90 can be rewritten as the square root of 9 times the square root of 10. That's a time symbol in between that. Excuse me. And what's the square root of 9? So 3 on the square root of 10 is the simplification of this problem right here. Everybody okay with that?
Are we going to be allowed to use
You need to be able to do this without a calculator at this simple level. So there might be parts of a test where you get a calculator and there might be parts of a test where you don't. Because some calculators you could type in 6 times 15 and it would give you the simplified radical answer. And I don't want you just finding that on the calculator. I want you to be able to actually do this. So I might give you a pop quiz tomorrow, or the bell ringers might be without a calculator or something. So you need to make sure you understand this procedure and you're not just calculator dependent. Everybody okay with that? All right. Go ahead and simplify this one.
That's the sixth fraction of the past one.
All right, so I would multiply 8 times 18. If you can't do that without a calculator, you could always set it up like this, old school. 8 times 8 is 64, carry the 6. 8 times 1 is 8, plus 6 is 14. And you should recognize that 144 is a perfect square. So what's the answer? 12. All right, this also works the same for division. So in division, just so long as both things are inside a square root, you can work division as normal. So square root 2 divided by square root 72 is the same thing as 72 divided by 2 under a square root symbol, which is 36. 36 is a perfect square, so that's 6. So that worked out easy. This one, we're going to have to check and see if it can simplify. So I would do 20, and I would prime factor it 2, 10, 2, 5. So that's
4 times 5?
square root 4 times square root 5, which is 2 on the square root 5.
I just threw up.
So that's the simplification of that one. All right. Is everybody okay with this?
Why don't we do another example?
Okay.
Because why don't we finish this?
Let's not do that one. Let's do.
I just wrote it down.
Let's do this. Actually,
You're very indecisive.
let's do this.
27. Okay.
All right. So what's 120 divided by 6?
50.
20.
It's 60. Dang it.
And it would be the same answer.
20, yeah, 20.
Alright, then that's going to be 2 square root 5.
All right. So that's square root 4, square root 5 is 2, square root 5. All right. So when I ask you to show your work, when I ask you to show your work, I'm okay if you just do this part right here. But I want you to at least give me this much. Know that you go from here to here before you do the final answer. Okay? Remember that for notebook check. All right. There is a rule in dealing with radicals that says you are not allowed to have a radical in the denominator. You cannot have a square root symbol in your bottom number of a fraction. Ever, ever, ever.
Square it.
That is a rule. So no, we're not going to square it because squaring it changes its value. But we can do something that's called rationalizing the denominator, which will multiply this number by something that doesn't change its value. What can I multiply any number by that doesn't change its value? I can multiply it by the number 1, right? If I multiply 2 over the square root of 2 by 1, it doesn't change its value. 1 comes in many, many forms. 1 could be written as 1 over 1, or it could be written as 5 over 5, or it could be written as 11 over 11, or it could be written as the square root of 2 over the square root of 2. Just so long as you have the same thing in the numerator and the denominator, that fraction is equivalent to 1. So what I'm going to do when I rationalize a denominator is I'm going to multiply its denominator by its exact value. Because if I multiply the square root of 2 by the square root of 2, I just created a pair. And that pair will be a perfect square. Whatever I put in the denominator, I'm going to put in the numerator so that that whole thing right there equals 1. And I don't change the value by multiplying it by whatever I created here. So that's going to be 2 over the square root of 2 or 2 times the square root of 2 over the square root of 4. However, what is the square root of 4?
2.
And then, since this is outside any radical and this is outside any radical, those can actually cross cancel, and you'll just be left with the square root of 2 as your simplification. A very, very simple process to simplify 2 over the square root of 2. By the way, this answer in and of itself will come up a lot when we start doing the special right triangles, and you'll have to be able to simplify it to this.
I mean, I can't contain my excitement.
All right, what would I do to simplify this one? Well, I might actually reduce it just enough so that the bottom has a perfect square. What can I do to 8 to make it a perfect square? What number could I can divide it by 2. So if I divide both the top and the bottom by 2, then I've created a perfect square in the denominator. And now all I have to do is simplify the numerator. So the numerator is going to be the square root of 9 on the square root of 2, which would be equal to 3 on the square root of 2 over 2. So sometimes you don't have to rationalize. Sometimes you can factor, reduce the denominator just enough. Now technically, if I completely reduce this, this would be 9, the square root of 9 over the square root of 2. And then when I rationalized it, I would get this answer in and of itself. I was just trying to save myself some work. All right, go ahead and do these two. All right, so when I did this one right here, I divided 70 by 2, and that took the radical out of the denominator. So now I just need to check and see if that will simplify. I go ahead and prime factor that, and it's 5 and 7. There's no pairs there, so that's simplified. So the simplification of square root 70 over square root 2 is equal to root 35. Here it's a little bit different. 2 won't go into 45, so I'm going to have to rationalize the denominator. That'll give me the square root of 90 over the square root of 4. And so let's see if 90 has any perfect square factors in it. So that's going to be 2 into 90 gives me 45. 2 won't go into 45, but 3 will. That gives me 15. And 3 will go into 15 5 times. So if I want to split 90 up into its pairs, not pairs, that's the square root of 9, 3 times 3, times the square root of 10, 2 times 5, all over the square root of 4. And if I take the square root of all my perfect squares, the square root of 9 is 3, and the square root of 4 is 2. So that's your final simplification of root 45 over root 2. Is everybody okay with that? Any questions? All right, there's your assignment.